Right, question 17 then. We're dealing with parametric equations now, so you'll see we've got the x and the y both defined in terms of t. T, we're told, goes between 0 and pi. Never ignore this. You may have to come back to it and pay attention to it at some point. So before we think too much about that, let's look at this. State the greatest and least value of x. X is just cos t. If we draw cos t between 0 and pi, well, let's just draw cos t, full stop. I say full stop, obviously it goes on forever, but let's just draw the standard wave of cos t. We're only interested in the bit here between 0 and pi, and you can see there that between 0 and pi it goes between 1 and -1. So the greatest value is 1 and the least is -1. Then for y, we've got sine squared 2t. Now I'm not going to sketch this one, but we're just going to think about it logically for a second. Sine of 2t goes between 1 and -1 because the 2t here affects the x-axis, or the t-axis in this case, horizontally, squashing sine in by a factor of 2, so it's still vertically going to go between 1 and -1. However, if you take 1 and -1 or anything between them and square it, it's going to make all the negative numbers positive, meaning that we're only actually dealing with things that go down as low as 0. So the greatest value is still 1 because 1 squared is 1. But the least value is 0, and anything below 0 in sine gets squared and becomes positive down to the minimum of -1, which is squared to give +1. So that confirms what I was saying there. On to finding the Cartesian equation. When you ask to find a Cartesian equation of parametrics where you are dealing with trig, you have to use identities that link the two together. So we've got a sine squared first of all, which we know is linked to cos using the sine squared plus cos squared is 1. Now, what that means is I can write my sine squared as 1 minus cos squared. So let's make a note of that first. And I could replace that with y. Now let's think about what we can do here. Can I replace cos squared 2t with something to do with cos t? Now if I ignore the square for a moment and just think of cos 2t, that's using a double angle formula to get it in terms of just cos t. So let's write that down over here. Cos 2, I'm going to use a for now, just to keep consistent with the generic forms. Cos of 2a is identical to 2 cos squared a minus 1. But we're dealing with cos squared. So cos squared 2a, just square both sides, would be the right hand side squared as well. So let's bring that over here, but instead of a we'll use t. So we've got 1 minus, and then we're going to replace cos squared 2t with this. 2 cos squared t minus 1 all squared. Now the reason I'm doing that is because now where I've got a cos, I can replace cos t, I can replace it with x. So because I have that squared, it's x squared that goes there. So we've got 1 minus, don't need the square brackets now, so 1 minus 2x squared take 1 all squared. I'm going to leave it there because it doesn't ask me to put this in a particular format. I could start to multiply out the double bracket here, tidy it up if I were asked to, but I've not been, so we won't do anything we don't need to do. On to part C. Find the exact coordinates of where the curve C, that's this curve here, meets the x-axis and the y-axis. I'm not going to use this because I feel like it would get more complicated than it needs to, so I'm going to stick with the parametric equations. We know that on the y-axis, x is 0. So if I make x here equal to 0, we get 0 is cos t. Now I sketched cos up here, and that is 0 at pi by 2 and 3 pi by 2. But we only want values of t between 0 and pi. So this one here, pi by 2. Now, let's substitute that into the y equation. Two pi by 2 is of course just pi, so we're dealing with sine squared of pi. Sine of pi, I'm just going to sketch that here, let's just write there cos and sine t, only because I'm going to need it again in a moment. There's pi, sine of pi is 0, so sine squared of pi is also 0. So it meets the y-axis at 0, 0. So let's carry on and look at where it meets the x-axis, because on the x-axis we know that y is 0. So let's have a look at that. I'm going to square root both sides. And now 2t is inverse sine of 0. Now it's tempting to go, well, between 0 and pi, that's just at 0 and at pi. But don't forget, we're dealing with 2t. Whenever you solve a trig equation where this is anything other than, we normally say x, but in this case t, we need to adapt the domain that we're dealing with here. So if t is between 0 and pi, then 2t is between 0 and 2 pi. So we do actually need to get values for this all the way up to 2 pi. So 2t could be 0, pi, or 2 pi, meaning that t could be half of each of these. So each 3 of those values, we are going to work out the corresponding x coordinate. So when t is 0, x is cos 0, and cos 0 is 1. So that gives me the point 1, 0. When t is pi by 2, then x is cos of that. Cos of pi by 2 is 0. So don't forget, for all of these the y coordinate is 0, so that gives us the point 0, 0 again, which we already had above. And then finally, when t is pi, x is cos of pi, and cos of pi is minus 1. So that gives us the point minus 1, 0. So we already found 0, 0 here. We got it again there because, of course, if it crosses the x-axis there, it also crosses the y-axis there. And we get these 2 points as well. So these 3 are our answers.